Okay, Russ Jackson, let's dive into setting up a new Rust project. So, we got this cargo new command. Tell us about that.
Yeah, Cargo new is the magic bullet for creating a new Rust project. It basically sets up the whole directory structure for you, making life a lot easier.
So, what does it do exactly? Just make the folders and files?
It does more than that. It creates a Cargo.toml file. That's where you specify things about your project, like its name, version, authors, and dependencies. It's basically the project's configuration file.
And dependencies? Like library dependencies?
Exactly. If you need external libraries for your project, you'll list them in the dependencies section. This is essential, like using libraries for financial modeling.
Got it. So, cargo new guessing game. That creates a whole new project directory with the guessing game as the project name?
Yep, you'll end up with a new folder called Guessing Game that contains all the necessary structure. It's pretty organized.
So you're saying it's like project initialization? A crucial step before coding begins?
Absolutely. It's the foundation upon which your project is built. Think of it as the initial infrastructure.
Okay, you mentioned cargo.toml. What's in there exactly?
It's a configuration file, right? It stores metadata about your package. The name, version, authors are all critical.
What happens if the author information is wrong?
Cargo will probably use defaults, but it's best to make sure it's correct. It's professional practice to update it.
And then, what's src/main.rs?
That's where the actual code for your program lives. The file to write your application logic.
So you build the project with the essential instructions to run, right there in the file?
Correct. Think of main.rs like the heart of your application.
Okay, so now you've got a basic hello world example. What does that cargo run command do?
Cargo run compiles your code and then executes it. It's an incredibly handy way to test changes quickly as you're building the project.
So, it's kind of a compile and run in one step?
Exactly. It's like a developer's best friend for rapid iteration and testing. Imagine iterating on a trading algorithm. You want to test the new part of the algorithm without rewriting everything.
Right, it sounds like a game changer for faster development. Thanks for explaining this, Russ Jackson.
You're welcome. Let's explore more of the details of main.rs next.
Great, let's do that. Welcome back to the show, Russ Jackson. Today we're diving into variables and storing user input in Rust. Let's start with the basics.
Right, Matthew. We're creating a variable to hold user input, essentially a container for data. Think of it like a designated parking spot for the user's input, ready to be used later.
So, what's this let_guess equals string? New line all about?
It's declaring a mutable variable called guess and assigning it a new, empty string. Let is how we create variables in Rust. Mut makes the variable changeable later. It's saying, here's a space called guess, and it'll hold whatever the user types in, and we can change that later. String, new, creates an empty string of a specific type, a string.
So, string, new, creates a new empty string. The colon is like a scope operator or something?
It's the associated function call for the string type. It means new belongs specifically to the string data structure. So we're using a function from the string set.
What about immutability? Is this guess variable fixed once it's set?
By default, variables in Rust are immutable. That means once you set the value of a variable, you cannot change it. The mut keyword changes that. It's like a lock on the space, and we want to unlock it to let the user input modify the string.
You mentioned read_line. How does that work exactly?
The IO, stin.read_line, and mut guess, line gets user input from the terminal. The read_line method takes the mutable variable, guess, adds the user's text to it, and stores it there. The and mut is critical. It gives the function access to the variable in a way that allows changing its content.
So, we're giving the function a reference to the variable for editing. It's not making a copy, right? Why is that important?
Exactly. It avoids unnecessary copying of data in memory, which is crucial for efficiency. This is one of Rust's strengths, making it fast for processing data.
So, Why not just use a copy instead of a mutable reference?
It could be done, but it can lead to issues when handling user input. This way, we can efficiently update the value as the user types.
Say a user types something wrong. Is there a way to prevent errors?
Yes, by wrapping the call in a result and checking for errors. In the example I've seen, they included .expect, failed to read line. That line immediately crashes the program if something goes wrong reading the input.
How does this connect to financial applications like trading platforms?
This concept of managing data input and storing it securely is vital. Imagine a financial application. The user inputs transaction details, and the program needs to store those details in a way that can be easily accessed and updated. This method ensures data integrity and efficiency.
Correct. Variables like this can hold different data types. For example, it could store price data, order volumes. The string type is great for holding textual input, and we'll need different types for financial calculations.
Awesome, Russ Jackson. Thanks for breaking that down.
You're welcome, Matthew. We'll continue exploring this fascinating world of Rust programming in the next segment. All right, Russ Jackson, let's talk placeholders in println. How do these work?
Okay, Matthew. So, println is a way to display output in Rust. These curly braces are like little containers.
Containers for data?
Exactly. They hold the values we want to show. The first set of curly braces grabs the first variable after the format string. The next set grabs the next.
So, if I have a variable like, say, a user's age.
Right. If age equals 30, then println, you are years old, age, would show you are 30 years old.
That's pretty straightforward. Can we print more than one variable?
Absolutely. Like println, x equals or and y equals x, y, shows both x and y.
So, x and y are just placeholders, right?
Yes, and you can substitute any kind of data, numbers, strings, booleans, just about anything.
That's fascinating. What if the values aren't in the right order?
You know, Matthew, the order matters. The first placeholder corresponds to the first variable after the format string.
So println, x equals and y equals yx would
produce the wrong result, swapping the values.
Got it. What happens if you have more placeholders than variables?
Rust throws an error. It can't fit the information.
And what if you have fewer placeholders?
If you have fewer placeholders, you won't be able to print all your variables.
So we need to be precise.
Exactly. It's a precise matching. This, in fact, is a key security feature.
So, let's say I need to display a username and password.
You absolutely can. Println, username, and password. Username, password.
What are some financial applications for this type of printing?
Displaying account balances, transaction summaries. All those outputs rely on string formatting.
What if you need to print a percentage?
You'd format it as a percentage. Println, the investment grew by the %, growth rate.
Neat. Are there any common mistakes people make with this?
Mismatched placeholders are a common error. You also need to ensure you use the correct data types.
Great insight, Russ Jackson. This has been incredibly helpful.
Happy to help, Matthew.
Thanks again, Rust. Welcome back to the show, Russ Jackson. So, we're testing the first part of this guessing game. Tell us, what's happening here?
Hey, Matthew. Okay, the first part just gets user input. Think of it like a simple prompt.
A prompt? Like asking the user for a number?
Exactly. The program asks the user, guess the number, and then waits for a response.
And how does it handle that input?
It reads the user's input from the keyboard. It's like, a little digital mailbox for the user's guess.
So, it's just capturing the number that's typed in?
Precisely. Then, it displays that number back to the user. It's echoing the input.
So, it's a basic read and display loop? That seems pretty straightforward.
Yeah, pretty fundamental, but important for building up more complex interactions later.
How would you use something like this in, say, a trading application?
You could use this input loop to get user input about specific stocks. It's the first step to allowing someone to enter buy or sell orders or input the amount of money.
What if the user enters something that isn't a number?
That's a great point. The program wouldn't know how to handle that right now. We'll need to add error handling to make the game more robust later. It's crucial for handling real-world situations where inputs might not be valid.
So, this initial input part is just a tiny piece?
Exactly. But a crucial piece. Think of it as the first brick in a wall. We need to build on this to make a complete guessing game.
Interesting. So, handling different kinds of inputs will be necessary for a proper financial application.
Absolutely. We need to validate and convert the input to ensure it's suitable for the application. We'll have to do more checks.
So, while simple, it's a foundational step?
Absolutely. Input and validation, the core of interactive programs.
What else do we need to account for?
Well, you need ways to interpret, confirm, or reject user input. These could be basic checks in the initial stages, leading to more complex validations later.
So, you think this is, in a sense, a bare minimum for input?
Exactly. We need to define the exact kinds of inputs the user can provide and what kind of responses the application will be giving.
Thanks, Rust. This makes it crystal clear.
My pleasure. Now, let's move on to the next stage.
Great. Let's move to the next part. All right, Russ Jackson, we're diving into generating a secret number. So, how do we make a truly random number in Rust? Something that's different every time?
Well, Matthew, it's not quite as simple as just saying random number. The standard Rust library doesn't have true randomness built in. Think of it like needing a special ingredient for a recipe that's not pre-packaged.
Right, a special ingredient. So, we need an external source of this randomness?
Exactly. That's why we need the Rand crate. It's a third-party package bringing a whole array of random number generating functionality to our projects. Like adding a new spice rack to your kitchen.
So, how does this Rand crate work? And is there a trade-off for using it?
The Rand crate gives us functions to generate various kinds of random numbers. Think dice rolls, lottery numbers. It relies on a source of entropy, something unpredictable, to make sure the numbers aren't predictable. Think of how a weather system isn't easily predicted.
Okay, so entropy is the key. Can you give us an example of how to use it?
Pauses, smiles. Well, imagine you want a random number between 1 and 100. The Rand crate gives a way to use that entropy to create the numbers. It's quite elegant.
Wow, this seems useful. How does this apply to financial modeling, for example, where you might need random numbers for simulating asset price fluctuations?
Excellent point, Matthew. Financial models often rely on random number generation for simulating various scenarios. By using this kind of unpredictable number generation, you can get more realistic price fluctuations.
Interesting. And are there any limitations or potential pitfalls?
Well, you'd want to be cautious not to use a source of randomness that's predictable or biased. Otherwise, your financial models could have skewed results and mislead your decisions.
So, ensuring that the randomness is truly random is critical. How do you do that?
The Rand crate provides ways to use seeds, which are a starting point to the random number generating functions. Think of seeds as a way of initiating a random walk in a random number space. A crucial detail for reproducibility if needed.
Right. Reproducibility. I get that. So we can have a repeatable process for generating random numbers, even with a random seed. That's very important. How about using those random numbers in game development?
Definitely. This kind of randomness in game development is absolutely vital for generating levels, NPCs, and other gameplay elements that add an unpredictable element to the game.
So Rand is important for both financial and game development scenarios?
Exactly, and many other applications too, In summary, the Rand crate is a valuable tool for adding randomness to our applications, a fundamental need in many fields.
Great explanation, Russ Jackson. We've clearly seen the value and importance of randomness in programming now. Russ Jackson, welcome back to the show. Today we're diving deeper into crates in Rust. So, what exactly is a crate, and why is it useful?
Hey Matthew! A crate, in Rust, is essentially a package of Rust code. Think of it like a library or a mini-program. You can have executable crates, which are programs you run, or library crates, which contain functions and data structures others can use in their projects.
So, a library crate is kind of like a reusable toolbox for Rust projects?
Exactly. It's a way to organize and share code. It promotes modularity and code reuse. Imagine a huge construction project. You wouldn't build everything from scratch. You'd use pre-made components, right? Crates are like those reusable components.
Okay, I see. Now what about these cargo.toml files? They seem crucial.
Cargo.toml is the configuration file for Rust projects. It's how you tell Cargo, the Rust package manager, about your dependencies. This is key for using external libraries.
Dependencies? Can you elaborate?
Dependencies are other crates that your project relies on. Like, if you want to use a random number generator, you have to tell Cargo that it needs the rand crate.
So, you have to declare what libraries you need?
Right, you explicitly list these dependencies in the cargo.toml file, and you specify the versions you need. This is where semver comes in.
Semantic versioning? What's that?
Semver is a standard for writing version numbers. It lets you specify the versions of crates that your project can work with without worrying about compatibility issues down the line. Version 0.3.14 means any version that's backward compatible with 0.3.14, simplifying things.
So, you tell Cargo which specific tools your project needs then?
You list the crate and its version. Then, Cargo fetches all the dependencies, along with the ones they need. This ensures consistency across the project.
What if the dependency has further dependencies?
Cargo automatically handles those as well. It's a smart system. It doesn't just get your declared crate, but everything that your crate depends on.
That's super efficient. But what happens if the RAN crate updates?
Cargo will manage that. If there's a new, compatible version, you can reuse the compiled version from the previous build. Otherwise, it fetches the latest version that's compatible.
So, you don't need to manually download everything?
No, Cargo takes care of everything, ensuring your project works properly with external tools. It's very efficient.
What are the potential pitfalls to consider when working with crates?
One issue is incompatibility. If you declare a crate with an incorrect version, your project might not compile. Always check the latest versions and compatibility.
And what if you have many dependencies?
Then it gets complicated because of potential version conflicts between packages. It's important to manage these dependencies carefully to avoid issues. It's like managing many different pieces of equipment in a factory. You need to ensure everything works together in harmony.
Makes sense. Thanks for that insight, Russ Jackson.
You're welcome, Matthew. It was a pleasure.
Russ Jackson, welcome back. Today we're diving into Cargo.lock, a crucial aspect of reproducible builds in Rust. Can you explain what it does?
Sure, Matthew. Cargo.lock essentially acts as a contract. It records the precise versions of your dependencies.
So, it's like a specific list of ingredients?
Exactly. It freezes those versions, preventing random updates that might break your project.
Why is this important? Say I have a game, right?
You bet. Imagine a crucial library, rand, needed for random number generation in your game. If a new version comes out, it might fix bugs but also introduce compatibility issues.
So, Cargo.lock stops that chaos?
Bingo! It locks you into a known, stable version until you intentionally update.
How does it actually work, this locking mechanism?
When you first build your project with Cargo, it analyzes your dependencies and determines the best versions. Then, it saves those versions to Cargo.lock.
So, it's like a time capsule for the dependency versions?
Precisely. Later builds automatically use the locked versions, ensuring consistency.
But what if there's a critical bug fix in a dependency, and I need that fix?
You'd manually update to the new version, and then update the Cargo.lock file.
So I have to update the lock manually?
Yeah, you explicitly upgrade the dependencies you need. But Cargo.lock ensures that's the only way to update.
Is there a way to enforce this immutability in the business world?
It's similar to using a standardized library version in a software project. Ensuring consistent versioning prevents unforeseen conflicts in projects. Imagine accounting software for a bank where version lock ensures correct financial calculations.
So, it's a practical example for financial software. Makes sense.
Absolutely. And conversely, if a crucial component for financial transactions has bugs, you won't have compatibility issues.
What happens if the Cargo.lock file gets corrupted?
You have to regenerate it. Cargo will reevaluate dependencies and create a new Cargo.lock. It's a manual process, and you might need to resolve any version conflicts.
So, what are some common misconceptions about Cargo.lock?
Some people think it's just about preventing updates, but it's also about stability. It's a necessary step for reproducible builds.
What about scenarios where you need to experiment with different library versions?
You can temporarily disable Cargo.lock, but remember, you'll lose the reproducible build advantage.
Okay, it's essential for reproducibility and preventing regressions, not just locking down dependencies. It's a powerful concept.
Definitely. It's a fundamental principle in software development.
Russ Jackson, thank you so much for breaking down Cargo.lock. Very informative.
My pleasure, Matthew.
Russ Jackson, thanks for joining us today. Let's talk about updating crates in Rust. You know, this cargo update command, how does it work exactly?
Cargo update is a powerful tool. It figures out the latest crate versions compatible with your project.
So, it bypasses the lock file?
Exactly. It looks for newer versions, but it prioritizes compatibility.
What does compatible mean in this context?
It means the version numbers match your dependencies. It's like ensuring your software components fit together.
But what if there's a new version that does fit, but it's not what I want?
Well, that's where you use Cargo.toml.
Explain that. What is Cargo.toml?
It's your project's manifest file. It declares your dependencies. You directly specify the version you want.
So, you essentially override the automatic updating?
Precisely. This allows more control, but sometimes things go wrong.
Like?
Imagine you need a specific version for stability reasons, or compatibility with older software. That's why manually setting the version can be crucial.
What are some common pitfalls people run into?
Not updating the Cargo.lock file after a successful update can cause build issues later.
How does this relate to financial applications, Russ Jackson? Are we talking about, say, a stable API?
Absolutely. Imagine an API library, crucial for a trading platform. You need that API to remain stable and functional. Manual updates, in such cases, can be crucial.
So, using a specific version directly in Cargo.toml ensures your financial software works smoothly?
Exactly. This predictability is paramount.
What if the new version is breaking changes? What happens then?
Then the update might break things. You have to carefully consider that. It's a trade-off.
Any other practical examples?
Updating a component for performance boosts is another example.
But what if the upgrade is unnecessary?
True, if the current version works, sticking to it is fine. You don't have to upgrade.
Okay, what about cases where the update might not be a straightforward upgrade, maybe a big change, or even a breaking change?
You would need to thoroughly test the update, understanding how it might affect other parts of your system.
So careful testing is key. What about the default behavior of Cargo Update? Only looking for versions greater than 0.3.0 and less than 0.4.0.
It's a default filter, ensuring backward compatibility.
What if a version is 0.3.15?
That's within the range. Cargo would usually update to it.
What about handling multiple updates in a chain?
Cargo handles the dependencies sequentially. It updates all impacted crates.
So, Cargo Update is about finding the latest compatible versions. Manually setting a version in Cargo.toml is more tailored to your needs.
Exactly. Understanding these tools makes Rust development more efficient, especially when managing dependencies.
Thanks, Russ Jackson. This is great.
My pleasure.
Russ Jackson, welcome back to the show. We're diving deeper into this guessing game project. So, we've added the RAND crate. What does that actually do?
Right, Matthew. The RAND crate, like many others in Rust, provides functionality we might not build into our core programs. It essentially gives us tools for generating random numbers.
Okay, cool. So, how does this RAND? Thread_RNG.gen_range 101 bit work? Break that down for us.
Sure thing. rand, thread_RNG, gives us a random number generator tied to the current thread. It's seeded by the operating system, so it's truly random. Then .gen_range, 1, 101, uses that generator to produce a random integer, in this case, between 1 and 100, inclusive of 1, exclusive of 101.
So, it's like picking a number out of a hat, but the hat is on a computer?
Precisely. It's pseudo-random, meaning it's generated algorithmically, but these algorithms are designed to create sequences that are very unpredictable. It's good enough for most practical purposes.
Why is use rand? RNG important?
That line brings in the RNG trait, which defines the methods for generating random numbers. This allows the code to use the gen_range method on our random number generator.
Interesting. So, this gen_range method generates a random integer between, say, 1 and 100, right? Is there a way to get different types of random outputs?
Absolutely. The rand crate offers various other methods beyond gen_range for generating other types of random data like floats, booleans, and more. This is why the documentation is crucial.
You mentioned the Cargo.lock open command. What's that about?
That's a fantastic cargo feature, Matthew. It builds the documentation for all your dependencies and opens it in your browser. It's a really handy tool for finding out how to use the different features and functions provided by these external libraries.
So, the secret number is generated once, and then?
The program prints the secret number, then waits for user input. This is a temporary step for testing purposes. In the final game, we'll remove that line.
What are some applications for random number generators in finance?
They're essential for things like creating realistic market simulations, modeling investment strategies and risk assessments, and in the generation of cryptographically secure keys.
Can you imagine a scenario where a biased random number generator could have significant implications in finance?
Absolutely. If a generator wasn't truly random, it could lead to skewed results in simulations, misinterpretations of market behavior, and potentially even significant financial losses or unfair advantages.
So, the rand crate is powerful and essential for this kind of game, and in many different domains?
Yes, Matthew. It's a fundamental tool for working with randomness in any computational context, and even more critical in fields where the validity and accuracy of results are paramount.
Great explanation, Russ Jackson.
Thanks, Matthew. Now, let's move to how users interact with the program.
Russ Jackson, welcome back to the show. Let's dive into this number guessing game. We've got user input, a random number, now we need to compare them. You got this cool listing 2 to 4. Can you walk us through the comparison process?
Sure, Matthew. We're using a match expression to handle the result of comparing the user's guess to the secret number.
Okay, explain the match expression.
The match statement examines the outcome of the comparison, which is represented by the ordering enum. Think of it as a decision-making tool. If the guess is smaller, it's ordering less; if it's bigger, ordering greater; and if they match, ordering equal.
So, how does this compare to something like an if/else statement?
A match is more exhaustive. It ensures every possible outcome is considered. With an if/else, if you miss a case, you'll have bugs.
I see. So, what's the core issue with listing 2 to 4 right now?
The code won't compile yet because the types aren't compatible. The user's input is a string, but we need a number.
What does the error message say?
It says mismatched types. Rust is really strict about data types. It can infer types sometimes, but not always.
How do we handle this issue?
We need to convert the user's guess from a string to a numerical type, like U32. We'll trim white space and use parse.
How does trim help here?
The user might type a number with extra space. Trim gets rid of that extra space.
Got it. So the parse method tries to turn the string into a number. But what if it's not a valid number?
That's a good question. Parse might fail, so we need to handle potential errors. We use expect to handle that potential error scenario, which crashes the program if the input is not a valid integer.
So the expect is like a failsafe?
Exactly. If the input isn't a number, it crashes and displays the error message we specify.
In real-world applications, how can you handle errors from parse without crashing the program?
You'd probably use a match or an if/else block to check the result of parse. For instance, you could print an error message and then prompt the user again for input.
If we had a financial application where user inputs represented an amount of money, how would you handle invalid input here?
You might want to display a custom error message and give the user a chance to fix the input. You'd need a more robust error handling strategy than the expect method in a production environment.
That makes sense. So, with this conversion, we can compare the user's guess to the secret number now, right?
Absolutely. We've got it in the proper numerical format now.
Cool. Russ Jackson, thanks for explaining this.
You're welcome, Matthew. We'll explore loops for multiple guesses in the next section.
Russ Jackson, welcome back. So, we're adding a break statement. Can you explain the significance of that in the context of a game loop?
Yeah, Matthew. Break is a crucial control flow statement. It essentially says, stop this loop right now.
So, it's like a game over button?
Exactly. When the user correctly guesses, we want to immediately end the program. The loop, in this case, is the whole game. When the user wins, the game is over, right?
Okay, so the break statement brings the loop to a halt. The program stops execution, right?
Correct. The break statement in this context is used to exit the loop and proceed to the rest of the program which, in this case, wouldn't have any code since the game loop is the last part of main.
And how does this relate to, say, a financial application?
Well, imagine a program that checks for specific market conditions. You might have a loop that monitors prices. If a certain condition is met, maybe a stock hits a certain price, you want to execute something immediately, like place an order. Break lets you exit the loop and take that action immediately.
Makes sense. Let's say, though, the user never guesses the correct number. What happens then?
The loop continues until the user guesses correctly, or some other error stops the program.
Okay, that's important. So, it's not just a way to stop the game, but to streamline the process if a certain condition is met.
Exactly. It allows the program to react dynamically to events instead of just continuing to execute every iteration.
Excellent. Now, what are the common pitfalls when using break statements in a loop?
Well, one common mistake is putting break in the wrong place. It must be inside the loop or some conditional inside the loop where you want to exit.
So, if you place it outside the loop, it might not do what you intend?
Exactly. It might exit the function, but not necessarily the loop. Another pitfall is forgetting it. If you intend for the game to stop when a condition is met, you absolutely need the break. If you have a loop checking database entries and want a break when an entry matches your criterion, that break statement is critical to efficiency.
Right. It's about strategic control flow. So, essentially, the break statement is another powerful tool for controlling the flow of execution in your code, making it more responsive and efficient.
Absolutely. It's a fundamental concept in programming that allows us to design more complex and robust programs.
Thanks for the insight, Russ Jackson. Really appreciate it.